C-section students also joined, no? 76 students are there. Is there any pending? Accept all. Okay. 77 students are there. Uh, so this is my CloudX lab. So yesterday I have discussed about how to implement pig in CloudX lab. How to implement pig in a CloudX lab. The same thing can be implemented in CloudX lab. The Hive also can implement the same way the CloudX lab. So the last class I have shown you how to SD3 dot pig. That is a projection. So some of students they have left the class lab, the yesterday's lab session. So this is the loading data using load command course details. So out of course detail, I want the only student ID. So dump out. So it is another thing. So I'm storing. I'm extracting only one column using for each given a tuple of bag consists of different collection of tuples. So out of the different collection of tuples, I am selecting only student id. So here next pig -x space sd3 dot pig. So it is a batch mode of running. uh, what is giving pig -x local. So I forget, sorry, local sd3 dot pig. So because the file so this is selected only student id from the uh, given table. So this is what sd3 dot pig extracting only a given thing. So here the student table, course table is there. Course table, um, the course table is available at home, Vaskar, Pig lab. So out of course table, I have extracted only student ID. So this is the final output you got. So I can get CD. You can check that CD ls-l course at course.txt. So see here, so I have selected only student ID. Student ID, what are the student IDs available? 1, 1, next 2, 4, 5, 12, 18. 1, 1, 2, 4, 5, 12, 18. So the same student IDs projected using by using pig. Using pig. So this is all about pig. How we can project, we can order, we can sort, um, everything you can perform. So leftover is CD. ls-l. Okay. So see sd.3 is there. sd 3.pig. sd4.pig. So I'm copying sd4.pig. So last over is left over is ordered by. Ordered by uh, ordered by group by, sorry, group by. So group by example is there. I will tell you. Yes, group by. Group by operation is data in one or more relation. Group by either group by used in statement in one or more relation. Jointly group tuples the from A and B. So that is the group by. Next dump, store, count. Ordered by, ordered. Already. Will tell you group by. So group operator. So Apache Pig has a group operator. So grouping the things. So group relation by age. So based on the student ID, I want to group. So you can make a group the some relation name. That relation name, whatever the relation you have created, the previous data or student data or some thing. So here a group student details by age. So the same way you can write here. So it is the data. So out of this out group, I'm writing here group course details by student ID. By student ID. So this is the grouping the all the students unique student IDs are going to be displayed. We'll run this program. That is big fnx local sd4.pig. So grouping all IDs. Student IDs. See here. So this is the grouping IDs. So first student ID 1. So first student is course ID is 3. The first student. So the first student different. So they joined in the different courses like triple E course is 3, and he joined in EC course is 2, and he joined in CSC also. Course ID is 1. Next, open elective selected for open elective. Next one is second student. Second student. So he has opted for only one branch. That branch is CSC only. Next, Third student. So he opted for EC course. That is a student ID for fourth student. Next, fifth student. So he opted for triple E branch. Next, 12th student ID. So he opted for the CSC. Next, 18th student. So he opted for ECE with course ID, that is 2. So this is how to group the things, grouping the things in the Hive. So the data already, the table already, you know the table. What is the table available? The previous execution. Yeah, this is the table. See this? So this is the table, and these are the student IDs. First, so there are 1, 2, 3, three courses opted by first student ID, student ID. So student ID, based on the student ID. So the course, first one is course ID, next student ID, next course. The first student so opted for CSC. Next, he also opted for EC. Next, opted for triple E. Opted for three only three courses. CSC, EC, triple E. So the same output you got here. Triple E, EC, CSC. Clear? So like that, based on the given data, you can group and you can form the things. Here, if you want to uh, get this, the what we call as nesting. Here it is. There is a nesting of tuples. So nesting of tuples take place here. This grouping is going to form a key value representation. Key is a corresponding column and value is corresponding relation. Key value pair. So values are nested tuples. So you can remove that nesting by flattening and tokenize. Flattening and tokenize things available in the pig Latin. Flattenize and tokenize. So this is the how to eliminate uh, eliminate the nesting of tuples. Bag nesting. So bag nesting can be eliminated by using flatten. Eliminates flatten. So tokenize is going to return new bag for each. So it is going to return new bag for after eliminating all the nested things. It is generating a new bag collection. So this is what you call as group by. And last lab I explained you regarding join operations, projections. So projection example. This is the projection example. Projecting only required column, required data, required column out of given uh, given data in a data flow language. So data flow language. The pig, that is the pig. So it is all about the pig. Do you have any doubts? Any doubts? Total 88 students are there. Any doubts? 510, 521, 531, 41. Any doubts, please? 49.
Sir, hello.
Any doubt?
No, sir. 41.
Okay. Okay, mute yourself. And already I told you some of the students they are having less attendance. Number 524 and 531, Jashwant and 31 are there in below 75. Coming to the C section, so many students are there. C5, D5, E9. So many students are there. D section, only 3 members are there. B section, 5 members. Why so many students are there in C section? I think 41 is out of danger. Out of there. Yes, you crossed the 41.
Yes,
Why
sir.
41? You
Yes, sir.
crossed the yesterday you met no. See, crossed the 75 percentage attendance. So don't worry. The two students, three students, five he already is in internship. For him there is no problem. Only thing is for 24 and 31, so they got less attendance. So there may be chance to detain also. So the correct thing is not showing. Exact the percentage is not showing. So you are below the. They are in a danger position. Try to attend all the classes. So number 24 and 31. So 24 is there. 24 is there. So what about 31? 31 also in danger position. Okay. So that is about your attendance. And next coming to Hive. So in Hive, how to create a table. So for getting the Hive, just simply type Hive in CloudX Lab. So it is giving you what you call as Hive shell. Or uh, so you can Hive shell. Type Hive shell, or you can simply type Hive. So both will prompt you to get into the Hive shell. Hive, clear in what you call as CloudX Lab. So now I want to create a table. Hive can be implemented in three different ways. One is a local mode. Three different ways are there. Local mode. Next, sudo the. So if you see the architecture, Hive architecture. So I can be implemented on HDFS. I can be implemented on local. I can be implemented on hybrid also. Hybrid. hybrid execution, that is by means of different JDBC, ODBC drivers. So by combining different programs also, we can run the Hive. So here in this, how the what you are seeing on CloudX Lab, it is a what you call as the CLI, Hive Client Interface. Hive Client Interface. So this is the Hive Client Interface. In CloudX Lab, previously they have given few also, HUE, few. So now, so they are not providing Hue. That is a Hive web interface. HUHWI, Hive web interface. What I have seen in the PPT, Hive web interface. So they are not providing Hue by the CloudX Lab. Only thing is to access the Hive is by means of CLI. That is a Hive client interface, command line interface. Command line interface. CLI is there. So through CLI only, command line interface only, you can access and run your programs. So here I want to show you how to create a table using insert into. So you can create tables in a Hive. The first one is how to create a um, database. You create a database. Here just simply create. Before that, show the displays what are the databases available. Show databases. Default there is a database. Apart from so many databases are there, so which are created by so many users. So these are the databases, list of databases. So the students who are having this CloudX account, so they can create the database, and these are the databases available in the present in a cloud by this CloudX Lab. Create the maintained by this CloudX Lab. So total so many databases are there. So total 1436 databases are there. So like that, if you create a database, that the database is also going to be available in this cloud, and it is maintained by CloudX Lab. So now I want to create database. So I am naming it for sake of college, Padlola Engineering College. So that is the database. I think so. No one, so nothing. No one may be created. So CG G. So in G. So there is no database starts with GU. GU two things are there. So this is the GU Godlavaleru. So three are there. So there is no good level database. So now I want to create the database. So it is created. So this is how to create a database simply, and I want to show the database now. You see here in this present database. So you will be having it will be showing our college database what I have created just now. See here. So previously, so there is no good level engineering college name as a database. In this uh, Hive that is maintained by CloudX Lab. So now I have created good level engineering college as a database. So now I want to use this database. So you have to type use. I am using database what I have created. Database does not exist. Gudlavalleru Engineering College, Gudlavalleru. I think I have given a wrong. So this is. I'm copying this. Use Valleru Engineering College. Fine or wrong entry? Valleru. So this is present database. So the created, and I'm using this. In this database, you can create the tables. So what are the tables you are creating? All the tables are going to be stored in this Gudlola Engineering College database. So you can you know how to create a table using Hive with create insert. So many things are there. You can create a table and you can load data, but create insert you can directly create as select also you can use. So many things are there. Uh, okay. For all this, I think already stored the data required. So that's why I will going to create a student database, so which is already created in Pig. The same table you can use. The syntax, create table followed by table name, row format delimited, fields terminated by stored as a text file. So that is the simple thing. So you can copy here, copy, create table, student. So I'm duplicating this to show the to know the what are the there in the. Okay, once again it is asking credentials. So in PigLab they have created a ls hyphen the student text is the CAD. All these are separated by comma. Fields terminated by comma and they are delimited by. So, so it is having student ID, SID followed by name, char array, first name, last name, age, next, age next, address, mm, I think it is phone number, next address. So total 1, 2, 3, 4 fields are there in the table. So create table, student. So like that you have to give SID, SID. So there is no space, int, comma, first name, first name, F name, or give FIR first also. First name, space, string, last name, space, string, next, age, int. Next one is phone, also string, comma, address, it is also string. So this is the schema, the column name and corresponding data types already given. Next, everything is created. Row format delimited by rows are delimited, and fields are terminated by comma. So, so row format delimited, fields terminated by. Single quotation, comma. stored as text file. O format separator. So table is created. So it is a. So now I want to show tables. So one table is there. So that is the name of the table is student. You can describe student. So this is how you can describe the schema of a table by using the describe uh, command. You can describe the things. Now I want to load data. So how to load data? So this you can load from the data from HDFS into this or the schema, or you can load from even from the local uh, local system itself. So where the data is available, so the present working directory. So that is the present working directory. That is student data available. So I am showing on another thing. So now I want to load data. So how to load data? So, so there is syntax to load the data. So created database is created. So this is the syntax to load data. Load data local import file name into table followed by table name. Or you can give some partitions also if you require. Load data local. Local is a I have confused yesterday. The syntax about Hive and syntax about pig. So in pig there is no need to view anything. You can simply load data, load single quotation file name. Whereas in Hive we have to specify the load data followed by uh, local import single quotation path name into table followed by table name. Local into table next the table name. So table name. Finally, if you want to create any partition, you can create. If you don't want to create any partition, you can simply omit that. So now I am loading this data. Load data in path single quotation. You have to give the location of where the corresponding um, the data is available. So I'm selecting this and I am pasting here. So that is the student dot txt. So that is the file which is available in our local system. So you have to give load data local in path data followed by local. Local is essential. So if you omit that local, automatically uh, load data local. If you not specified in the command, automatically if the keyword is not there in local, it is nothing but automatically going to search for from the HDFS path. So here local is required. Load data local. Load data local in path into table followed by table name. Into table, what is the table name? Student. The table name is student. Semicolon. So it is loaded data. After loading, um, so it is giving you number of files, number of rows, and total size. It is storing how much data, total size. So everything is displaying. So loading data into good level engineering college dot student. So it is a database name followed by student. So now I want to can write SQL queries like select all star from student. So this is the data which is retrieved from the table. So total how many fields are there? So it is fetching 16 rows. Total 16 rows are there. So everything is fine and everything is displaying in a Hive. So this is how to create and run the queries on what you call as uh, on the given database what you have created. So like that you can create the external tables also, external tables and internal. So the table what you have created is the local table. So for external tables, you have to use external table. Create external table. External table is nothing but uh, which is created in the HDFS. So even though the data may be lost, the schema persists. That is what is called as external table. Uh, and these are the comparison between the external table and internal table. As a SQL queries, you can run what are the queries you want. Select answer from student where age is greater than age 25. So age greater than 25, nothing is there. 24, 24 also no record is available. So greater than 22. So will give greater than 23. Only uh, one, two, three records are there. So ID with 7, 8, 17 and 18. So they are having 24, age 24 and age 24. So like that you can access the data in Hive. Uh, You can create external tables also. You can access data, and you can practice in the same way the required things, just like join, all the what are this available in the syllabus. So everything you can practice in CloudX lab also. So external tables, Hive internal tables. Uh, so they are going to store in a user Hive warehouse. External tables, so they are going to store in HDFS. So how Hive moves data into warehouse directory? How it moves data into the Hive does not move table into warehouse directory. It is going to store entire data into the HDFS. Drop deletes table data and metadata. Dropping, if you drop a local internal table, the entire data and metadata will be lost. If you drop the external table, so it deletes, dropping deletes tables metadata. So it metadata will be deleted. The data will be persist. Support truncate. No truncate support is there. Support ACID transaction. No ACID transaction support. Query result in catching works. Query result does not work. Catching result. The load statement internal table, you can simply give that syntax. Internal table Hive command stores in the directory. So that is the loading data. Load data local in path. Already I explained you. Load data. Next, whereas external table, if you want to store the data, so loading data external table creates above. Here you have to externally specify creating external table. Table external demo. Loading also you have to load from the HDFS location. సో క్రియేట్ చేసేటప్పుడు ఎక్స్టర్నల్ అని పెట్టాలి. టేబుల్ బదులు ఎక్స్టర్నల్ టేబుల్. క్రియేట్ ఎక్స్టర్నల్ టేబుల్. Already name is there, that's why it is giving error. Just wait for a minute. The table is created, stored as a text file. So show show tables. So two tables are there. One is student, another one is student one. Any doubts? So thank you one and all for joining this class. So subsequent classes will teach you the remaining topics in the Hive lab session. And time permits, I will provide you the PDF for lab also. So thank you one and all. You can leave now. Any doubts?
Sir, experiment